Hi, in this video, I will be showing you problem number 23 of chapter 5, section 2 from the practice exam. Use the form of the definition of the integral given in the theorem to evaluate the integral. Integral negative 2 to 0, 5x square plus 5x dx. So this is a problem where you have to evaluate the integral in a specific method known as Riemann Sum method. That's what the theorem is about. The definite integral by Riemann Sum is integral a to b fx dx is the same as limit is n approaching infinity sigma I varying from 1 to n f of x I delta x, where delta x is b minus a over n and xi is a plus I delta x. This we will recognize f of x, a, b and delta x and xi. F of x is the integrand which is 5x square plus 5x, and a is the lower limit which is negative 2 and b is the upper limit which is 0. Then delta x from the relation b minus a over n which is 2 over n. Xi is a plus I delta x, where a is the lower limit. So negative 2 plus I times delta x from the earlier step is 2 over n. First let's evaluate f of xi delta x, and then we will take the sigma and then take the limit, and then we will get back to this step for the theorem. So this is our step 1. So f of xi delta x, so you're going to replace x with xi, so it is 5xi square plus 5xi. And delta x, which we have already evaluated, which is equal to 2 over n. Now we also know what xi is, so it is 5 times xi squared, so it is negative 2 plus 2i over n the whole square, plus 5 times xi, which is negative 2 plus 2i over n, the whole thing multiplied by 2 over n. So that is for delta x. Now we have to take the limit and also get back to the definite integral part. So now let's take the sigma and then take the limit. So limit n approaching infinity, sigma I varying from 1 to n, f of xi delta x, which is pretty much the expression in this step, which is equal to limit n approaches infinity, sigma I varying from 1 to n. Then we have these expressions 5 times, we can expand this, negative 2 plus 2i over n the whole square, which is 4 minus 8i over n plus 4i square over n square. That is the first part. Then if you distribute the 5 here, that is negative 10, positive 10i over n, then the whole thing multiplied by 2 over n. So we have here limit as n approaching infinity. Then we can even take the 2 over n outside, 2 over n. Then we'll take the sigma and distribute the sigma. Before we distribute the sigma, it is 1 to n. Then we can actually distribute, that will be 20, then that will be negative 40i over n, and this will be 20i square over n square, minus 10 plus 10i over n. So we get limit as n approaching infinity 2 over n. We'll keep the sigma as is. We will simplify the inside. So it is 20 minus 10, that will be a 10. Then we have negative 40i over n plus 10i over n. That will be a negative 30i over n. Then we have 20i square over n square. Now we can take the sigma, we can distribute the sigma to each one of the terms. Limit as n approaching infinity. Then first we are going to have sigma I varying from 1 to n 10. So this is actually 2 over n times sigma of 10, sigma I varying from 1 to n of 10. Then we have minus, if you distribute these two, we are going to have negative 60 over n square sigma I. Then we are going to have plus 40 over n cube, then times sigma I square. So we notice 2 over n, sigma 10 would be, sigma 10 means 10 is added to itself n times, so it is 10n. Then 60 over n squared sigma I, by the formula that we wrote in the previous problem, it is n plus 1 over 2. The understanding is this is sigma I varying from 1 to n. Here also it is sigma I varying from 1 to n. Then 40 over n cubed sigma of I square, again by the formula that we wrote in the earlier problem, it's n plus 1 to n plus 1 over 6. So we can do some amount of simplification over here. This will be 30 and this will be 20 over 3, and then this n can be cancelled out with the n cube, that gives an n squared below. So it is limit as n approaching infinity of, here it is 20 minus 30 n plus 1 over n. We want to write that as 1 plus 1 over n divided by n is 1 over n. Then we will write this as 20 divided by 3. Then we have n plus 1 to n plus 1 over n square. So n square can be written as n times n. We will take one n with the denominator as the denominator of n plus 1, another n as a denominator of 2n plus 1. So when we simplify this, n over n, 1 over n, and then 2n over n, which is 2, then 1 over n. So we write like this. Then the reason for writing this is, we notice that 1 over n approaches 0 as n approaching infinity. So we have here, after we allow n to approach infinity, it is 20, then we have minus 30, then 20 over 3 times 2. So that will be negative 10 plus 40 over 3. So when you simplify all this, you get negative 10 plus 40 over 3, which reduces to 10 over 3. This is by the evaluating the integral by Riemann Sum method. So always, as I said, these problems can be checked by the regular antiderivative process that you learned. So for this problem, it is integral negative 2 to 0 5x squared plus 5x dx, negative 5x squared plus 5x dx, negative 2 to 0 5x squared plus 5x dx. So by fundamental theorem of calculus, we write this as 5x cubed over 3 plus 5x squared over 2. You can even take the 5 as a common factor outside. So if I take that out as a common factor, I will have this one, 5 is taken out, and then between the limits negative 2 to 0, negative 2 and 0, which is 5 times upper limit, it is 0. At the lower limit, it is negative 2 cube, which is negative 8 over 3, plus negative 2 square, which is 4 over 2, which is 2. So this is going to be 5 times 8 over 3 minus 2. When you simplify, it becomes 5 times 2/3, which is 10 over 3, which is exactly the same answer that we got by Riemann Sum method. So the first part, we did by Riemann Sum method. Say if they tell you to use Riemann Sum method or the theorem, this is the longer way you would do, but always there is a shorter way to check your answer by directly integrating it. Hope this video helps.